Bé, aquesta recepta és un aioli tradicional. Un aioli tradicional com estem acostumats ara a menjar-lo. L'aioli tradicional seria només amb all i oli, però aquí farem una mica de trampa i posarem una mica de rovell d'ou. El fet és que aquest rovell d'ou ens serveix per poder-hi posar menys quantitat d'all. Aquí agafem l'all, traiem la part dura de dins i el posem a dins el morter. Farem per un rovell d'ou 2 grans d'all, grans. Obrim. Ja ho tenim a punt. És important, perquè no ens marxin els alls volant, posar-hi una mica de sal. Hi posem una mica de sal i el comencem a picar fins que obtenim una massa ben fineta. Agafarem l'ou i ara això és una mica de truc, Veus? Tenim el rovell aquí dins. I posem el rovell. No el sabíeu aquest, encara? I ara hi posem el rovell. I podrem començar. Un dels trucs és ajudar-te d'una mica d'aigua calenta. Aigua calenta, unes gotes d'aigua calenta quan toqui. Començarem a muntar un bon oli d'oliva verge d'una acidesa baixa, 0,4 graus d'acidesa. Aquí tenim un siurana o un les garrigues, un oli català molt bo. I començarem. Primer hem de començar molt a poc. I després podrem anar fent.
So an emulsion is drops of an immiscible fluid in a second fluid. Drops of one fluid in a second fluid. A foam is the same thing, except instead of using a fluid on the inside of the drops, you use air, a gas. So how do you make an emulsion? Well, the best way I can show you is to do this little experiment. Here I have olive oil and water, and I'm going to try to mix them together. And olive oil is not miscible in water. And when I pour the olive oil onto the water, it floats on top. It's lighter than the water. So the only way I can mix them is to shake them. So let me shake them like this. And look, they do mix, but they don't completely mix. Instead, you form drops of the oil in the water. And that's an emulsion. But let's watch this for a little while. We put it on the side, and remember, the oil is lighter than the water and is going to start to float to the top. And as it floats, the drops become closer and closer, and they begin to join together, and they lose their stability. The emulsion doesn't remain drops of one fluid and another, but rather phase separates, becomes the two fluids again. And if you look at them, and if we watch them over time, you'd see they completely phase separate. So this emulsion is not stable. So how do we make an emulsion? An emulsion is a mixture of one fluid in a second by making drops. For example, in this case, we've made oil drops in water. The oil drops are now called the dispersed phase. The water is called the continuous phase. And to make an emulsion, you have to mix them together. Somehow, you have to form drops of the dispersed phase in the continuous phase. And when you do that, you get these drops, and that's your emulsion. But to make them stable, you have to prevent the drops, or you have to keep the drops as individual drops. You can't allow them to join together or coalesce. Somehow, you have to stabilize the interface of the drops of the oil in the water. And we do that using a surfactant. A surfactant is a surface active molecule. It's an amphiphilic molecule. Part of it is water-like or hydrophilic, and the other part is oil-like or hydrophobic. And they're joined together. So the surfactant molecules like both the oil and the water. And they can't really decide which they want. So they can't really sit in either the oil or the water. Instead, they prefer to sit at the interface, at the surface between the two fluids. Typically, you put the surfactant in the continuous phase. So if you have an oil and water emulsion, you put the surfactant in the water. So part of the surfactant sits at the oil. There's excess surfactant, however. You need to have excess surfactant so that you always have more surfactant available so that it can come to the interface as you create the interface when you're emulsifying something. The surfactant has to come out of the water and go to the interface. However, the surfactant does not like to stay in the water because it has part of it which is oil-like. It doesn't like to be in water. So instead, the surfactant forms aggregates. We call these micelles. The aggregate, so that the tail groups, the oil part of the surfactants, are all connected together. They're all facing one another, excluding some of the water, that allow the surfactant to exist in the water without exposing the tail groups to the water itself. But the micelles act as a reservoir. They can easily break up and bring new surfactant to the interface as you create the interface. And if you have enough surfactant, and egg yolk, for example, is an excellent surfactant, they completely coat all the interfaces. And then, when drops come together, as I show here in this little cartoon, when two drops come together with a coated interface, with a surfactant-covered interface, it prevents the drops from joining together and becoming larger drops. So the drops remain stable and the emulsion remains stable.